Okay, so let's look at our second example here. Again, we're using trigonometric substitution. We're going to define our u and our a. U is what we have to square to get the function piece, and a is what we have to square to get the number piece. When I look at this, I notice that what I have is the a square plus u square. Doesn't matter what order it appears in. I think on your sheet it says a square plus u square. That's the same thing as u square plus a square. So that the substitution we're going to make is we're going to let u be equal to a tangent of theta, which means then that the radical of a square plus u square will be equal to a secant of theta. So going ahead and doing that, we are going to let our u, which is x, be equal to our a, which is 4 times the tangent of theta. And then that means that the radical of x squared plus 16 has to be equal to a, which is 4, times the secant of theta. Then step 2 says we're going to use this original x equal form here to go ahead and find dx. We do that by taking the derivative of x with respect to theta, and when we take the derivative of the tangent of theta, we get the secant squared of theta. Then multiplying both sides by d theta to get the dx all by itself, we get that dx then is equal to 4 secant squared of theta d theta. We're then going to take these things and we're going to substitute it back into our original integral. That's our step 3. Everywhere we see a radical, we're going to put in a 4 secant of theta. For a single x, we're going to put in a 4 tangent of theta. And for the dx, we're going to put in the 4 secant squared of theta d theta. So we get the integral then. We have a single x on top, which is going to give us 4 tangent of theta divided by the radical, which is going to be 4 secant of theta. And we're going to multiply that by dx, which is 4 secant squared of theta d theta. This 4 will cancel with this one. One of these secants will cancel with this one. And we wind up with simply the integral of 4 secant of theta tangent of theta d theta. And this is a very simple integral. We just get 4 secant of theta plus c. The last and final step of this is to go ahead and use our right triangle technology. So again, we're going to go back to our original substitution that x was equal to 4 tangent of theta. We're going to go ahead and solve this for tangent of theta by dividing both sides by 4. And I'm going to get that the tangent of theta will be equal to x over 4. By definition, this is going to be the opposite over the adjacent. So let's go ahead and create ourselves a right triangle. And again, you don't ever want to use the 90-degree angle as theta, but either one of the other ones can be your theta. It doesn't make any difference. Let me pick a different one this time. Then I'll pick the last one. Makes no difference because we're going to read everything off of it. So the opposite side is x, the adjacent side is 4, and remember what I said, because the substitution that we're making is based on the Pythagorean theorem, I guarantee you that if you use the Pythagorean theorem, that third side will always be whatever your radical is. Then based on this triangle, we can take our answer, which was 4 secant of theta plus c, and convert it back over to x's by using the fact that secant is equal to the 1 over the cosine. So the secant is going to be the hypotenuse over the adjacent. So this is going to be 4. The hypotenuse is the square root of x squared plus 16 over the adjacent, which is 4, all plus c. And so we get our final answer, which is the square root of x squared plus 16, all plus c. Let's do one more simple example of this, and then we'll do our last video, which will compare these 3 methods. And again, I'll compare these methods to all the other ones and put our process in place. And again, even though I can do a U substitution, I am going to do a trigonometric substitution on this. So I need to define my U, which in this case is equal to X, and I need to define my A, which is equal to 3. In this case, I have a U square minus A square. Remember, if there's a plus between them, the order doesn't matter, but if there's a subtraction, the order does matter. And so when we have U square minus A square, we use the substitution that U is equal to A secant of theta, which means then the radical of U square minus A square will be equal to A tangent of theta. So let's go ahead and put in our U and our A, and we get that X is equal to 3 secant of theta, which means the radical of X squared minus 9 will be equal to 3 tangent of theta. Sorry about that tangent there. Okay. So now we're going to go to step 2, and in step 2 we need dx. We get that from using our x equal form. So x is equal to 3 secant of theta, and if I take the derivative of x with respect to theta, I get 3. Derivative of secant theta will be secant of theta tangent of theta, and then solving for dx by multiplying both sides by d theta, I get that dx is equal to 3 secant of theta d theta. Again, we're going to come back now for step 3 and substitute that back into the original integral. So I see that I have a single x on top here, which is going to give me 3 secant of theta. On the bottom, I have my radical, which is going to be 3 tangent of theta. And then I have my dx, which is going to be 3 secant of theta tangent of theta d theta. The 3 cancels with the 3 on top. The tangent of theta here cancels with my tangent of theta there, and I just get the integral of 3 secant squared of theta d theta. Very simple integral to do. Integrating 3 secant squared of theta gives me 3 tangent of theta all plus c. Step 4, again, is to do our right triangle technology. And you're doing this, you always go back to your original substitution, which was that x was equal to, 3 secant of theta. Let's go ahead and solve that for secant of theta by dividing both sides by 3. And we get that the secant of theta is equal to x over 3. By definition, this is the hypotenuse over the adjacent. So again, we'll go ahead and create ourselves a right triangle. Remember, never let theta be the 90-degree side, but it can be any of the others, angles, not angle sides, not angle anyway. So I let it be this angle here. The hypotenuse will be x, the adjacent side will be 3, and I guarantee you that the side that's missing will be that radical. Again, you can do the Pythagorean theorem if you need to prove it, but because the identities we're using are based on that, we're guaranteed to get that result. And then taking our answer, which was 3 tangent of theta plus c, and knowing that the tangent of theta is equal to the opposite over the adjacent, this is going to give us 3. The opposite side is the square root of x squared minus 9. Adjacent side is 3 plus c. So we simply get the square root of x squared minus 9 all plus c.